Good afternoon, everybody. We are going to get going. I see there's still a few people joining, but we'll get going with today's webinar. So you're all really welcome to today's webinar on semi-supervised learning. This is the fourth webinar in our Masters Series. And it's nice to be back after the summer break. In terms of our panel today, I suppose the agenda, first of all, we're going to have our panel discussion. So for those of you who've been on our previous webinars, you'll be used to this format. So we're going to have a 15-minute panel discussion, just talking around topics like what is semi-supervised learning, how is it used, hints and tips from our panel. Then Brian's going to lead us through a bit of a tech session on how you can apply some semi-supervised techniques. And then we'll have a Q&A session from our audience. So just to introduce the panel, so we have Dr. Bogdan Sacaleanu, hopefully I've pronounced that correct, Bogdan, who's from Accenture Research Labs here in Dublin, based in the dock in Dublin. So really excited to have Bogdan here to share all his insights on semi-supervised learning and how they're using it in Accenture and beyond. We have our very own Dr. Brian Mac Namee, who's our Director of Training Krisolis, but is also a lecturer in UCD, and yours truly. I have the very nice task this morning of just hosting today's panel, so I just get to ask questions, which is kind of nice. So we're going to kickstart our panel discussion. So hopefully now you can see all three of us. So we're going to start off. I'm just going to ask my two fellow panelists to introduce themselves, and I suppose what they do and how they might, maybe an introduction to how they're using semi-supervised learning a little bit at the moment. So we'll start with Brian.
Thanks for that, Aoife. So I'm, as Aoife said, Brian Mac Namee. I'm the Director of Training at Krisolis. So through that, I design a lot of our courses and I deliver a lot of our courses, and in particular try to look at new and kind of upcoming things in data analytics and data science. So what's the thing that you're going to want to use next? They're all the things that I look at, in particular focus on developing courses in. The other thing that I do is I'm also a lecturer in UCD, where I teach in the computer science department. I teach machine learning. I also lead a research group there, and I'm director of a Center for Research Training in Machine Learning. And one of the particular things that we're looking at there in our research is looking at how we use machine learning in sort of new and different applications. So things like a lot of sort of supervised machine learning has become reasonably standardized at the moment. So one thing we're always looking at is, well, how do we bring machine learning to other places? And one challenge when we do that is a lack of labeled data. So anyone who works as a machine learning practitioner has probably faced this problem where you come up with a good idea for a project, you talk to a client or a partner about doing it, it all looks great, and then you say, where's the data? And say, oh yeah, no problem, we've got loads and loads of data. And you say, great, now where are the labels that we're going to use to predict? And they say, oh, we don't have any labels. So we have 6 labels, or we have 10 labels, or we know someone who maybe has a label somewhere and we'll go and try and track it down. A lot of the research we do around things like active learning, semi-supervised learning, and other approaches to interactive machine learning is trying to solve that problem. So to look at how can we make machine learning work effectively in those scenarios where we don't have as much labeled data as we'd like.
Thanks, Brian. So I might move on to Bogdan and ask Bogdan to do the same, to introduce himself, so maybe a little bit about Accenture and what you do there.
Yeah, thank you, Eva. So my name is Bogdan Sacaleanu. I'm the research lead for the Accenture Labs in Dublin. So Accenture Labs, it's a unit in Accenture which mainly concentrates on research and development within new areas of artificial intelligence. So we have about 7 labs which are spread across the globe. The biggest one is in Dublin. And in terms of work, so the main focus of the lab in Dublin is artificial intelligence, and we have areas ranging from computational creativity to workforce intelligence to knowledge discovery and knowledge graphs. And so, yeah, so as you can assume, so most of the work leverages machine learning, both traditional and newest deep learning. So, and yeah, happy to be part of this webinar.
Great, thanks Bogdan. So now I'm going to start with a nice easy question for Brian. Just explain to us, like, what is semi-supervised learning?
So I think the easiest way to think about semi-supervised learning is it's where we want to apply machine learning techniques when we don't have labeled data. So often we think about machine learning in terms of supervised learning versus unsupervised learning, and where the key distinction is whether we have those labels that we're going to use for a target variable in our supervised learning problems. So if we do have those labels for a target variable, we're doing supervised learning, we'll do things like train gradient boosting models or decision trees or neural networks or whatever it might be. Unsupervised learning will apply things like clustering. Semi-supervised learning kind of sits in between. So it's where we'd like to do something quite like supervised learning, but we don't have a large labeled data set available to us, or we potentially don't have a large labeled data set available to us. There's a few different things that we might want to do. One of the things that we might want to do there is often known as transductive learning, and the job there is I have a big collection of unlabeled data and I'd like to apply some labels to it. And there's a particular set of semi-supervised learning techniques for that. Things like label propagation, co-training, some of those interesting techniques can allow us to do that. And one nice application I worked on in that once was looking at astronomical data, where large sky survey telescopes are hoovering up lots and lots of data, but astrophysicists who want to work with that data need those images from those telescopes to have labels so that they can go and say, oh, give me 1,000 images of galaxies of this particular type, or give me something that has a red shift of X. None of those labels exist in that data, and the volume of that data is so big that you can't manually apply those. You can't seek to manually apply those to all of the data that's available. So what we'd like to have is to have machine learning techniques that can apply those labels automatically and do that fairly accurately with minimal human effort or labeler effort. That's what we know as transductive learning, and that's the job. And the key distinction there is the thing that we want to get out of that is a labeled data set. And lots of times it's used in those instances when we want to augment or expand a data set that we have available to us. The other big use of semi-supervised learning that at least I see and that I work on is where we want to do inductive machine learning. We want to build something like a predictive model, but we like to not only take advantage of labeled data, but also to take advantage of unlabeled data. And there's kind of two cases where we might want to do that. One is where we just don't have enough labeled data, right? So there's a scarcity of labeled data and we'd like to correct for that, right? We have a lot of unlabeled data available there, but we only have a small number of labels. And that often happens, particularly in things like predictive maintenance or fraud detection or something like that, where maybe labels just don't exist. The second use of it that we might have is where we have a labeled data set. We probably have enough to train our machine learning model, but we also have a large collection of unlabeled data that we'd like to take advantage of. So there, as we have this data resource, why not use it? And that brings in interesting techniques like pseudo labeling is a good example there. And then there's lots of little things that maybe can fall under the banner of semi-supervised learning, like self-learning, one-class classification, and weak learning as well. We might talk about those as we go along. But the short version is where we want to take advantage of both labeled and unlabeled data in building machine learning models.
I like that. That's the short version. I don't think I'd like to hear the long version. Oh, sorry. Bogdan, I suppose in terms of when we talk about all the different machine learning type approaches, I suppose where does semi-supervised learning fit in, and how is it different from standard machine learning?
Well, if it is to compare it to supervised and unsupervised learning, like Brian mentioned, right? So in supervised learning, you already have the labels for your data. You know exactly to what classes they belong to. So the main task in there is to develop a model that is able to kind of learn a function that when new unseen samples are being presented will be able to identify them correctly. So unsupervised learning is when you don't have any labels at all. So and the machine is supposed to do its best to figure out what could be the distribution behind those samples that generated the data. So, and a good example is clustering, where you don't have any clue about which are the labels, which might be the potential classes of your data. And then you let the machine learning process the data and identify groupings of those samples that seem more similar to each other. And like Brian said, so the unsupervised is somewhere between those two, where you can leverage both data which comes with labels, but at the same time data which doesn't have any labels. And it's trying to identify some hints from the unlabeled data that will be helpful for the supervised algorithm in classifying and learning from more data than usually available.
Excellent. Thanks, Bogdan. So I suppose we might go back to you, Brian. And are there any specific problems, like use cases, that where you've seen semi-supervised methods used quite successfully?
Yeah, so in terms of use cases for it, so we currently, for example, have a project that we're working on where we're using semi-supervised learning. And the project there is doing image classification for agriculture. So there's a lot of really interesting work going on at the moment. We do it at Krisolis, and I do it at UCD as well, in looking at how to apply machine learning to agricultural scenarios. And the particular project we're working on at the moment, where we're using some semi-supervised learning, we are taking pictures of the grass in fields, and we're trying to assess the amount of, or the composition of that grass. So if you're a dairy farmer, one of the things you're quite interested in is basically what kind of makes up the grass that you're looking at, or that your cows are eating. And it's things like, is it grass, is it weeds, or clover is one of the key constituents of that. So what we're looking at developing is image processing techniques that a farmer can take a picture of the grass in their field and automatically determine what's the composition of it. Currently, the way that that's done is somebody gets down on their hands and knees with a scissors, trims off bits of the grass, brings it back to a lab, separates it into grass, clover, and weeds, and then weighs those different components. Obviously, to do that using image processing would be brilliant, because it'd be much, much faster if we could do it accurately. One of the problems we have is we don't have a large label data set. So we have to do some label collection or some data collection there. So we are taking some images. Getting the labels for those is very expensive, because somebody has to do that job with the scissors. But getting the images is actually quite easy. So the plan and the aim here is that we can take images that are taken on something like a phone. So we can have people walk around walk around a field with a phone and hoover up lots and lots of images. But we can't get lots of labels for those. So in that case, we're turning to semi-supervised learning techniques to get prediction models that will have the kind of accuracy that we need. We're going to have small data sets, we know that, small labeled data sets, but we can have very large unlabeled data sets, and we want to take advantage of both. So that's one place where we're seeing really good benefits of using semi-supervised learning. So the accuracy of the models that we're managing to build using both the labeled and unlabeled data is much higher than using just the small labeled data sets alone.
Excellent. And I suppose, Bogdan, I'm going to have the same question for you, because I'm sure in labs in Dublin, you've kind of lots of nice examples of how you're using semi-supervised methods. So do you have any good ones that you can share with us?
Right, and that's so I'm referring to a case study that we did for Hewlett Packard Enterprise, where kind of the task was to support them in integrating older systems with newer systems, and they had a bunch of old records that had to be mapped to the newest records. And we are not talking about thousands or 10,000s, we're talking about millions of records. So what they were doing this task mainly manual, that somebody looked at the older records and tried to map them to the newer records. So then we came in and we set up the whole solution like a machine learning based solution, where the task was the user is manually labeling just a small set of data, And then this small set of data has been passed to an algorithm which was trying to identify automatically what is it that makes those samples very similar. So it was trying to learn a similarity function. And then that similarity function has been used to cluster the data. So, and once the data has been clustered, those clusters and kind of the representative examples of the clusters were presented to the user for a validation, and they were then automatically labeled. So instead of taking something like, before they were annotating 160 records per day. So with this semi-supervised method where the machine is doing the clustering and then it's presenting representative of the clusters, and they had to label only those representatives. So we were able to increase their productivity to 2,500 records per day. So which is almost 20%, 20 times higher than what they did before. And yeah, and another example was in the area of the pharmacovigilance, which is kind of looking for solutions to identify adverse events to a specific drug. And it was exactly the same problem. So there is no kind of standard corpus there or set of data which will show you for which drugs, which are the adverse events. So, and the problem is even worse with the newest drugs. So for the newest drugs, you don't have a clue yet what are the adverse events, because it takes a couple of years till all the data is being gathered. So we were working together with a pharma company that were very interested for their newer drugs to identify, so what might be the potential adverse events based on the publications coming from the scientific publications coming from sites like PubMed. So, and it was a very similar, so we took a few examples. We had humans which manually annotated adverse events for the newest drugs. And then the machine went there, was looking at the context in the text of those annotated examples, was learning about the context, and then automatically extended that to other contexts which looked similar, but they were unlabeled, and extended the labels. So, and the main benefit it was in here that the smaller number of manually annotated samples could be, whatever has been learned from those could be propagated to millions of unstructured data, and extended automatically the label to those samples. And by doing that, so we had finished by having a huge amount of training data that was improving the accuracy in the order of 10 times than before.
Super, they're great examples. So I suppose now we know a little bit about what semi-supervised is and the types of areas that we can use it for. We're going to head over to Brian, who is going to do a quick demo for us of how you can use some semi-supervised methods practically. So Brian, it's over to you.
Great. Thank you for that. I'm going to share my screen. Hopefully you'll all be able to see that. So I'm going to work through a quick demo here of showing active learning. So I guess in both of those examples that myself and Bogdan talked about, we talked about how we want to get minimal amounts of human input, but take advantage of large collections of labeled data. And what active learning is one of the nice approaches that we can use to do that. It kind of fits in that category of interactive machine learning. We're going to have a person involved in the process. So I'm going to look through a simple Python notebook. So we've got some code here to show this off. It's relatively raw so that we can see under the hood and see what's happening. A few bits and pieces I've run before. I'm going to use all the kind of standard packages that we might use in Python notebooks. So I'm going to use scikit-learn, I'm going to use a little bit of keras. And this modal is a nice package that implements some key active learning algorithms. Now, the problem I'm trying to solve here is I have this nice data set, and all things going well. This is where we hold our breath and say this is a real demo. I have this nice data set of pictures of flowers, and some of them are sunflowers and some of them are daisies. And what I'd like to do is train up a model that can tell the difference between a sunflower or a daisy. And I'd like to do that using this unlabeled data set that I have here with kind of minimal input from me as a human labeler. There's a couple of thousand images here. It's not an enormous data set, but it should be enough for me to be able to build a model that can do this job. And this is kind of a nice example for the kind of applications where we might want to use these kind of techniques, where maybe I have this almost throwaway machine learning problem where I'd like to do this thing to be able to tell the difference between daisies and sunflowers, but maybe I just want to do that now because I found this big collection of images and I'd like a little bit of help in sorting it. But it's not like a model, like maybe something like a credit scoring model where I'm going to spend a long time tuning it and put in a huge amount of effort. So here's my starting point. I've got these pictures of daisies and sunflowers. There's a lot of variation in here. There's lots of interesting things going on. I'd like to make my prediction model to tell the difference, but I've got no labels yet. And that's a typical starting point for active learning. Now I'm going to use a little bit of a pre-trained, a little bit of transfer learning here. So I have a pre-trained VGG16 model that's been trained on ImageNet. I'm going to chop off the end of that and use the embeddings that it generates for me to represent these images. And that's a really typical thing to do, particularly because I'm going to work with this at the beginning, at least, with a very small data set. So I'd like to take advantage of this transfer thing that we get from deep learning now. So I've done that already, and I'm going to jump straight down through this. There's this code that kind of helps me do that. This takes a little bit of time to run, so I ran that already. And all things going well now, I have this data set that's going to be the input now for my active learning process. So I've taken the embeddings from that pre-trained VGG16 model. The type of active learning that I'm going to use here is called pool-based active learning. And what pool-based active learning is going to do is interactively build a prediction model where at each iteration in that interaction that I'm going to have, me as a human expert, I'm going to label some images. So it's going to show me some pictures. I'm going to label them as either daisies or sunflowers. And in the process of doing that, the model is going to get better and better. The clever thing that active learning does is it's going to try and choose the ones that I need to label. So a little bit like Bogdan just talked about in his use case, it's going to look across this set of images and try and decide which ones are the useful ones for me to have a look at and provide a label for, and then which ones are, I guess, similar enough to ones I've labeled already that it's not worth my while. And we're kind of looking for two things here. We're looking for a little bit of exploration and exploitation. So we want nice representative images that maybe the labels can propagate out to a bigger set. And we also want those kind of hard to classify ones so that my model will get a little bit more and more accurate. I'm going to set up my active learning process here. So the key thing in this is I'm not using any of the labels here. I called it pool-based active learning. So all of the unlabeled data set starts off in the pool. And then what I'm going to do is pull just 10 random examples from that. So here's my 10 random examples. There's 10 random pictures. You can see a few daisies and a few sunflowers. And I'm going to label those. So here's my little interactive bit. And we can guess what's this? Well, it's a daisy. What's this one? It's another daisy. This one is another daisy. This one is a sunflower. This one is another sunflower, another one. They're probably daisies. These guys are sunflowers. They're sunflowers. And that's my first little bit of labeling done. So now I have an initial data set and I can get up and going. There's my data set. There's the labels I just provided, 0s for daisies and 1s for sunflowers. And now I can get into my key active learning loop. So here's where I'm using that mod.al package, which is a pretty nice one. One of the slight challenges in doing some of the semi-supervised work is some of the semi-supervised techniques aren't as, let's say, maybe mainstream as some other machine learning techniques. So we have to use maybe a broader set of packages. Scikit-learn, for example, doesn't have active learning support in it. From looking around at these, mod.al is a pretty good one that I've used for a few different things. This is the main thing now, is so I have a little bit of labeled data. My active learning object is going to look at that data and now pull out a batch for me for labeling. So I said, give me a batch of 10 more pictures for me to have a look at. So there's the 10 pictures that it's pulled out. What it's looking for here is to try and select ones that are either representative clusters or are around the decision boundary that's going to help the model learn to tell the difference between those tricky cases of daisies versus sunflowers. And I can see a few tricky ones turn up here already. I get back into my labeling loop. So I think that's probably a daisy. There are daisies. There's a tricky one. I'm going to go sunflower. on that one. In the way I've set this up, I don't have a don't know option. That'd be a useful thing to throw out an item, because it's useful to do a little bit of data cleaning as we do this too. I think that's a sunflower. There are daisies. There are more sunflowers. There are more sunflowers. There are more sunflowers. That is a daisy. More sunflowers. And on we go again. So now I can see there's my extra set of labels that now get into my labeled set. And now here you can see I teach the active learning object these new labels, right? So I'm going to say, go have a look at this and essentially tell me what you think. I'm going to manage my data set a little bit here. So I move things from the training set into the, or out of the pool and into the training set, so I can go back around with this. And that's the idea essentially with active learning, that I'm going to go through this interactive process of providing labels to the machine learning algorithm so that it can get more and more accurate. It's selecting the things that it's worth my while looking at. Now I can cheat a little bit here. So I have previously prepared a validation data set that I can have a look at, so I can just show you, whether this is improving or not. So I can have a quick look and see, well, how good is this at the moment? Right, so it's not doing a great job. You can see from my confusion matrix. So let's do a quick second lap through this. So I can select another batch. Right, here's some more pictures. So again, these are ones that are perhaps tricky to the model at the moment. I'll go through that labeling process again. So there's a daisy, there's another daisy, there's a sunflower, another daisy. There are daisies, daisies, sunflowers, sunflowers, and daisies. So I've given it another 10 examples. Again, it's going to teach that to the model. We'll update our data set. If I do another iteration, it'll select a different set based on what it knows so far. But hopefully I can have a quick look at the accuracy, and you see we've taken a jump already. So we were down around 60% in terms of average recall before F-score. We're up to 70% now. You can see that high number that was at the top right of our confusion matrix here, shifting over to the left. Now, if I keep doing that again and again and again, my model will become more and more accurate. And if I look at this chart from here's one I read earlier, or ran earlier, here's the big thing that we're looking for here. So this is showing the performance of the model as I add more and more labels. And in active learning, what we see all the time is this nice curve, right? So this nice, big, steep curve at the top, and then things flatten out very quickly. And what this tells me through these kinds of experiments is that with a small number of labels, I can get a very accurate model. And I can get as accurate a model as I'm going to get with lots more labels, right? So you can see in this case, this flat line of performance across the top that we get here. So after maybe 100 or 150 labels, I've done about as good as I'm going to do. So I can get that performance with way less manual labeling effort than if I went in and labeled the whole data set. And for me, that's a real nice application, or a nice example of how we use active learning, where we want to build a model. We don't have labeled data, but we have access to a large pool of unlabeled data. I'd like to do pretty well, but I'd like to do it without an enormous amount of human effort, because either that human effort is just a pain, or that human effort is expensive because it's time consuming, or I need experts. Looking at daisies and sunflowers is pretty easy, but if I was looking at x-rays for something like a medical application, or if I was looking at sort of slightly complicated documents for a document processing application, that could cost me an awful lot of money and an awful lot of effort to do that full labeling that I don't really need to do. So that's pretty much the demo that we wanted to show here. I hope that gives an illustration of what's involved in this active learning scenario, which is one example of semi-supervised learning. There's a few challenges with this. So one of those is, typically I don't have this validation data set. So I introduced this here so I could show, as I do those labels, I'm getting an improvement in performance. So typically we need to have some other way to stop. Often that's driven by a labeling budget. So I have, an afternoon of someone's time to do labeling, so I get as much labeling as I can, or I'm maybe paying for labeling. So I have an actual financial budget that I want to use for that, or something else. And there's other ways to do it, but there are some of the challenges. But where active learning is particularly useful is if I have that access to unlabeled data, I want to build models, and maybe I want to build those models where I'm not going to put in the effort to do huge manual labeling. They're not so crucial that I'm going to tune them to death. I want to get something up and going. I want to get it up and going pretty quickly. And here's a great way to do that without that massive manual labeling that we typically need to do. So I'll stop that demo there, but I'm happy to answer any questions about that or go into any of the other details that I might have skipped over in doing that. And I'll stop sharing my screen and jump back.
Excellent. Thanks, Brian. I hope people found that useful, and I suppose to see these techniques in action. Sometimes it always surprises me how with relatively small amounts of code you can actually solve, you know, some quite nice problems. And we've all been in that scenario where we, you know, go on site, we get some data and somebody goes, oh yeah, we don't actually have any labels. So I mean, it's a nice example of how maybe you might be able to build up a labeled data set without a huge amount of expert input. So I suppose now we're going to move into kind of our Q&A session. So if anybody wants to, you can either use, so to answer questions, you can just use the chat. So the webinar chat and questions will come through to us. Or there is, if you look down the bottom of your screen, there is a Q&A panel. So if you use the Q&A panel, everybody will be able to see them. If you just use the chat, I think they come directly through to the panelists here. So I'm going to kick off with this while we're waiting for people to type in their questions. And I suppose, Bogdan, from a practical point of view, what are, I suppose, the challenges that you've seen kind of faced in using some of these methods? Are there any kind of things that you would warn people, kind of pitfalls or challenges that you would see people using semi-supervised methods?
Well, like Brian said, so one of the challenges in semi-supervised learning is knowing when you have enough data and knowing how good the data that you have annotated is, right? So like Brian said, so he had something that he could check, you know, if he's going in the good direction or it's just making the algorithm be even more confused. Well, sometimes that is, so you need to really, so if you do the labeling, you need to work with subject matter experts. So sometimes, you know, so even if you think that the task is pretty easy and you can identify, let's say, a daisy from a sunflower, we've seen that there are some really very tricky cases, like Brian said, you know, so where he would prefer to say, I don't know, or remove it, you know. So if you are working with experts, so they will be able to say that, you know, so it was either a daisy or a sunflower. So, but sometimes if you are not working with experts and they are just taking a guess, so that information that gets fed into the machine learning algorithm might be introducing more noise than really information. So yeah, and the other one, it's like Brian said, you know, so when will you stop? You know, when do you think that you have enough? You know, so, and sometimes we've seen it also on our side. You know, so sometimes our stop was, let's say, the financial budget, and then we realized that well, we have to double it or to stop on it because it was not enough in terms of quality and quantity, right? So that's kind of so working with SMEs for doing this kind of labeling, and also having a good feeling when you have enough data and good enough in terms of quality. So these are kind of the tricky questions to answer.
Excellent, brilliant. Thanks for that, Bogdan. I think it's always that golden question when you're starting out in a project: how good is good enough? In a lot of the projects that we work on. So that's some great insight there. And I suppose, Brian, you mentioned some of the packages that you use there, and I realized that Brian actually can't be seen when he's talking, and that's because he's actually sitting beside me, and he's muted his microphone, so he's just going to lean in so he can be seen on my video. So now you can see him twice. 2 for the price of 1. That's how we roll here. So I'm going to ask Brian, I suppose, in terms of infrastructure and packages, kind of what's out there in terms of both, I suppose, we saw there's some Python packages which you can probably download, or is there anything from a commercial point of view that you know on the market?
Yeah, no, that's really good. So there are packages. So the one I used, I said, is mod.al, is a nice Python package. There are other ones. So there's a number of different Python active learning packages. As far as I can tell from my looking around, that there isn't one that has become kind of that standard one in, let's say, the same way that something like scikit-learn has for lots of other machine learning. So it takes a little bit more looking around. There's a question of why Python and not OR. I just happen to use Python. I typically jump between those. Whichever one I've taught a course in most recently is the one that comes out of my hands most quickly and easily, and I happen to have Python in my head at the moment. There are packages in OR. I haven't used any of the active learning or other semi-supervised learning packages in OR extensively, but they definitely are out there. Broader than active learning, so another semi-supervised learning techniques, things like pseudo-labeling, label propagation, and things like that. Some of those are, for example, scikit-learn has a couple of those implemented into it, but a lot of them are going out to things like GitHub repositories and smaller packages to find them. For active learning, there are a couple of companies who do this. So there's a company that was Crowdflower. They changed their name again. I think they're called Appen at the moment. They're one of the big ones that does a lot of this. So they'll use a lot of active learning work. Essentially, they're a data labeling company. They do a lot of interesting things with that. And then people will often use, as a sort of front end towards doing this, something like Amazon Mechanical Turk as a way to get those labels. Now, you usually have to do the work in putting something in the background to drive that process. But I think Crowdflower is now called Appen, is the one that I've seen get most traction. There are other ones out there, but that's one that I've seen as being most popular. And it's interesting that those commercial services are out there as a way to drive that labeling job, essentially.
Excellent. And I suppose, Bogdan, have you any, I suppose, other examples of where semi-supervised learning has been used, or where you see it being used kind of down the line? So anything that's happening out there that you've read about, or that either you're working at an Accenture that you've looked at and went, oh, actually, that's kind of interesting?
Well, if you're referring to further use cases, yeah, so we've been working with industry clients, for example, on how can we automatically generate new formulas for dish washing liquids. And this is where we used semi-supervised learning, because as you can imagine, so they had a limited number of samples, but they were looking for, okay, so and this was part of the computational creativity, just give me something creative, give me something that our subject matter experts would not think of, right? And that's where we leverage GANs. So GANs are by nature unsupervised. But there is a way to inject, labels if you have access to them. So we use GANs to come up with a model which learned the distribution of those formulas that we had, and then injected kind of what we knew from the client, that it's a good formula and a bad formula. So by doing that, so whatever has been predicted then as something new, something surprising, so not something that a user or a human will be coming with. So we injected the label data to make sure that we get rid of those that were already known, and the results were only really novel formulas.
Super, that's really interesting. It's like one of those examples where, next time you're walking down the supermarket aisle, you look at dishwasher tablets, you're going to look at them differently now. I love it. I suppose, just in terms of, to finish up, because I don't see any questions coming through, so if people do have questions, just type them in. I suppose, Brian, again, in terms of future work, where do you see semi-supervised methods being used more?
Yeah, so I think there's a few different things that are happening. One particularly interesting one that there's a lot of work on now is looking at how we can do similar things that have happened in natural language processing with the sort of transformer type models like BERT and GPT-3 that there's a lot of publicity about at the moment. We can do similar things with other data sets. So that idea of self-learning is really interesting, and it's relatively easy in text. I guess people have been doing it for a long time in text, where you can take just a big collection of documents and you can train a model to do things like next word predictions, that kind of language model training. And it turns out that the things that you learn doing that then can then be applied to all kinds of different questions. So if people have been following those stories about GPT-3 in particular, and you can see that, you know, this one model is being used for all kinds of different things. People are trying to do similar jobs for other data sets, in particular images. So we haven't seen this exactly the same kind of advances in images, and people are doing really interesting things now using techniques that are often referred to as contrastive learning, where we take images, we manipulate them in some way, and then we train models to do things like recognize the manipulations, or even recognize that things are the same image after those manipulations, or other simple tasks like that. And it falls into that category of self-learning, where we're trying to do is use, again, this unlabeled data that we have, but learn interesting representations of that data without having a specific task in mind. So then we can apply those representations to lots of different things. And that definitely fits that semi-supervised model. The other one that we're seeing quite a bit of is the idea of weak learning, which I think is really interesting, where it's a kind of a little more nuanced than saying we don't have labels. It's where maybe we have really solid, reliable labels, and then we have less solid or less reliable labels. And we'd like to take advantage of all of those. And you end up doing things like designing clever loss functions to pay more or less attention to different bits of that. And I see really interesting things happening in those areas.
Super, excellent. Well, it looks like we're coming up to our time limit. And I know people probably have lunch to get and things like that. So I'm not going to keep people any longer. So I suppose, first of all, I really want to thank Bogdan and Brian today for giving us time and talking us through kind of what is a really, really interesting area. And I think we're going to see more and more people using semi-supervised methods for all types of reasons. And I know when we're kind of talking about it from a training perspective, how it's that idea of using algorithms that sometimes were designed in a supervised context or non-supervised context and augmenting them for something different, which I think is always kind of fun and interesting. So thank you so much, Bogdan, particularly for giving us up your time today. We really appreciate it. Also, this has been recorded, so it'll be up online. So anybody who wants to go back and look at either the code or anything that we discussed, you'll be able to see it online in a little while. Also, just in terms of, and this is where I go back to PowerPoint. In terms of our master series, as I said, this was our fourth webinar. I have to just share my screen. Hold on. 2 seconds. Apologies, taking. So this was our semi-supervised session. And this is our webinar. We do have an online masterclass. So if this topic is of interest to anybody and you want to learn more about it, we do have a masterclass coming up in September for this. So get in touch if you want to learn more about that. And also then later in September, we are talking all things reinforcement learning, which has been a bit of a hot topic for us. I know people have been talking about it and asking us about it a lot recently. So that hopefully will be an interesting one that's coming up in September in terms of the webinar, and then we have a masterclass running in October. So really excited for both our masterclasses that are coming up at our next webinar. So tune in for our next webinar if you want to learn all about reinforcement learning. And again, as I said, if you want to learn about semi-supervised learning in more detail, let us know if you want to take part in that masterclass. So to finish up, as always, so we'll be sending out feedback forms, so it'll be really interesting to get your feedback. We always appreciate it. There will be some discount codes going out, and it won't be for a deep learning masterclass, it'll be for the semi-supervised learning masterclass. And obviously, if you want more information, just get in contact. And thank you both to both of our panelists this morning, and to all of you who logged in and listened to us going on about what is probably a little bit of a technical subject compared to some of our other topics, but I think really interesting and what they're learning about. So thank you all for taking part. Really appreciate it. And at that point, I'm going to say goodbye. Stay safe. Chat to you all soon.
Thank you, Eva. Thank you, Brian. Thank you, everybody.